I'm Adam from RFOXiA from our real lab. Today we're answering why does your GNSS module lock onto one constellation when four are available, and what does that choice actually cost you? Enjoy our new soundtrack at the end of the video. Picture a bar, four bartenders. GPS has been working this shift for decades, knows every regular, never misses an order, shows up on time, reliable. Galileo is European, precise, slightly formal, newer on the job, but genuinely excellent. GLONASS is Russian, has opinions, works a slightly different frequency, but covers the northern latitudes better than anyone else in the room. Beidou is the newest hire, covers Asia Pacific with density that the others cannot match, and is quietly becoming the most capable of the four in certain regions. Now, most GNSS modules you buy walk into that bar and only talk to GPS, not because the other three are bad, not because they conflict, but because talking to all four simultaneously requires more engineering, a more capable chip, and more attention to RF design than most module manufacturers are willing to spend at the price points they want to hit. So GPS is working the bar alone, the other three are standing right there, and your fix accuracy, your acquisition speed, and your reliability in difficult environments are all worse for it. Let me explain what you actually lose. The first thing you lose is geometry. GNSS positioning works by triangulating your location from multiple satellite signals. The more satellites you can see from different angles in the sky, a value called the dilution of precision or DOP, the more accurately the receiver can resolve your position. When you lock to GPS only, you are limited to the satellites in that one constellation that happen to be visible from your location at that moment. Some of them are low on the horizon, some are clustered on one side of the sky, some are temporarily blocked. Your geometry is whatever GPS gives you, and you have no way to supplement it. When you add Galileo, GLONASS, and Beidou, you are suddenly drawing from a combined constellation of well over 100 active satellites instead of roughly 30. The geometry improves dramatically. Your DOP number drops, and when your DOP drops, your position accuracy improves, not because the signals are better, but because you are solving the same geometric problem with far more data points from far more angles. This is not a marginal gain. In open sky with good satellite visibility, multi-constellation can take you from 3 to 5 meter accuracy down to 1 to 2 meters. In degraded environments, it is the difference between a usable fix and no fix at all. The second thing you lose is first fix time. When your module powers on cold, no almanac data, no prior location estimate, it needs to find satellites fast. A GPS-only receiver is waiting for GPS satellites to come into view and acquire signal. A multi-constellation receiver is hunting across four systems simultaneously. The probability of acquiring a sufficient number of satellites quickly from any orientation in any part of the world is simply higher when you are not restricted to one system. That translates directly to cold start time. The Multinav Pro Plus achieves first fix in 1 second. A GPS-only module in the same conditions may take significantly longer depending on satellite geometry. The third thing you lose is regional coverage. GPS was designed by the United States. Its satellite distribution reflects that. GLONASS was designed by Russia and has exceptional coverage at high northern latitudes where GPS geometry degrades. Beidou has exceptional density across Asia and Oceania. Galileo covers Europe with higher redundancy than GPS in that region. If you are building something that operates globally, a drone, a tracker, a research instrument, and you have locked your receiver to GPS only, you are accepting that your hardware will perform unequally in different parts of the world. Multi-constellation means the hardware performs to its specification everywhere, not just where GPS geometry happens to be favorable. The fourth thing you lose is resilience. GPS signals can be jammed, they can be spoofed. Individual satellites have maintenance windows and signal anomalies. A GPS-only receiver has no cross-reference. If the signals it is receiving are degraded or manipulated, it has no independent data source to compare against. A multi-constellation receiver receiving independent signals from four separate systems operated by four separate governments on four separate frequency bands has an inherent cross-check. Spoofing all four simultaneously is not practically achievable in the field. Jamming all four simultaneously requires substantially more power and bandwidth than jamming one. The resilience advantage is real and it is not small. Now here is the thing the industry does not explain clearly. Multi-constellation capability is not just a checkbox. The RF design matters, the antenna matters, the chip matters. A badly designed multi-constellation module can perform worse than a well-designed GPS-only module because the additional signals introduce interference if the RF front end is not properly filtered. the microstrip filter design, the antenna gain characteristics, the chip's correlation channels. All of it has to be engineered correctly or you are just adding noise. The MultiNav Pro Plus uses the u-blox MIA M10Q, which is u-blox's current generation chip designed specifically for concurrent multi-constellation operation. It handles GPS, Galileo, GLONASS and Beidou simultaneously so that is the geometry problem. One constellation leaves you with whatever satellites it feels like giving you. Now let me show you the hardware that solves it. This is the MultiNav Pro Plus built on the u-blox MIA M10Q. That chip is doing something most modules at this price point structurally cannot, running GPS, Galileo, GLONASS and Beidou concurrently, not sequentially. Simultaneous lock across all 4 constellations means your geometry is always drawn from the widest possible pool of satellites, 1.5 meter accuracy and an 18 Hz fix rate. The fix rate matters more than most people realize. At 18 updates per second, a drone moving at speed has a position sample every 55 milliseconds. GPS-only modules at slower fix rates introduce positional lag that compounds with velocity. Multi-constellation geometry closes that gap at the data level. 26 by 22 millimeters at 25 to 30 milliamps, this runs comfortably on battery-powered platforms with no thermal concern. The compact footprint means you can integrate it into airframes, wearables and trackers, where a larger module is a design constraint, not a choice. Multi-constellation does not have to cost you size or power. UART and I2C on the same board, with 1.8V and 3.3V logic compatibility. This means the MultiNav Pro Plus talks to whatever microcontroller you are already using, STM32, ESP32, Arduino RP2040, without a level shifter in most configurations. The interface flexibility is there by design, not as an afterthought. The full driver library is open source C NMEA standard protocol and imports cleanly into Arduino IDE or any toolchain that speaks serial. You are not waiting on a proprietary SDK or a vendor's release schedule. You pull the library, you parse the NMEA sentences, you have latitude, longitude, altitude, and fixed quality from all 4 constellations in your application within an afternoon. uCenter is the u-blox configuration GUI, and it is the correct tool for evaluating what multi-constellation actually looks like in real operation. You can watch individual satellite signal strengths from GPS, Galileo, GLONASS, and Beidou updating simultaneously, see the DOP value drop as more satellites contribute to the fix, and confirm that the hardware is performing exactly as the physics says it should. Drones, wearables, trackers, automotive, research instrumentation, IoT nodes. Every one of these applications has a different answer to the question of where in the world it operates. The MultiNav Pro Plus gives the same answer everywhere, all 4 constellations concurrent, the strongest fix the geometry will allow, regardless of location. Filter specifically to manage interconstellation interference. The integrated chip antenna is tuned for the full multi-band receive profile, not just L1 GPS. This is not 4 systems running sequentially or on a time division schedule. They are running concurrently all the time, with the receiver continuously selecting the best satellites across all 4 systems to build the strongest possible fixed geometry. The 4 bartenders are all working the same shift simultaneously, and your accuracy reflects it.
Constellations up above, locked in orbit, signal love. 18 fixes every second, every meter calculated. No drift, no guess, no hesitation, just the truth of your location. 1.5 meters from the truth, every coordinate living proof. GPS, Galileo, GLONASS aligned, Beidou locked exactly where I am. Precision at the speed of land. Fast moving platform, still it holds. Signal strength that never folds. Sky above becomes a map. Every second fills the gap. Urban canyon, open field. 4 constellations never yield. The sky is full of signals, waiting to be heard. physics confirmed. Nowhere on this planet falls outside the grid. 0.5 meters margin, that is all there is. 1.5 meters from the truth. Beetle locked exactly where